Welcome students. Now today we will start with the second exercise of chapter 2 polynomials. Exercise 2.2. Find the value of the polynomial 5x minus 4x square plus 3 at, and there are three parts for this question, at different values of x, at x is equal to 0, at x is equal to minus 1 and at x is equal to 2. So you can see over here the polynomial given. Can you tell me what is the degree of this polynomial or what type of a polynomial it is? See carefully. There are three terms in the polynomial. Therefore, this is a trinomial and the highest degree is 2. X raised to the power 2 is the highest degree. Therefore, this is a quadratic trinomial. So, this is clear now how to find what is a polynomial type, which type of polynomial it is. So now let's start with the question. So first is x is equal to 0. So what do we have to do over here? We have to put the value of x 0, means wherever in the polynomial it's mentioned x or it's written x, we will put the value 0, means we will just substitute the value of x as 0. In whichever places we have x, we will keep 0 over there. So from the start we write px is given, so we write it as p0. So p0 is equal to 5 multiplied by x. Now what is the value of x we have over here? 0 minus 4x square. Again value of x is 0 plus 3. So now you know 0 multiplied by 5 will give you 0 minus 4 multiplied by 0. Again you will get 0 and plus 3. So the answer is only 3. 0 raised to the power 1 or 0 raised to the power 2 or 0 raised to the power anything will always be 0 only. Now the second part, x is equal to minus 1. This means wherever we have x, we will keep the value minus 1. So now we will substitute the value of x in the given polynomial. P of x means p of minus 1 is equal to 5x. 5x means 5 multiplied by minus 1 minus 4. Again it's x square. So instead of x square I will write minus 1 whole square. Keep that in mind. Minus 1 is whole square. You have to keep the sign also inside it. You have to square the sign also. Plus 3. So minus 1 into 5 will give you minus 5. Then minus 4 into minus 1 square is 1. You know that minus 1 multiplied by minus 1 will give you plus 1, because minus multiplied by minus sign gives you plus. So minus 4 into plus 1 will remain minus 4 plus the last constant term which was 3. I'll write over here plus 3. So what I am left with is minus 9 plus 3. So the answer is minus 6. Third question, x is equal to 2. So now I will put the value of x as 2. So I'll put px, means I will write it as p2 is equal to 5 into x, means 5 into 2, minus 4x square, means I will write minus 4 multiplied by x is 2 whole square. So I'll do 2 whole square plus 3. So I will get 5 into 2, which is 10, minus 4, and 4 2 square is 4 itself. So minus 4 multiplied by 4 will give you minus 16 plus 3. So the answer is plus 13 minus 16. So the remainder left is minus 3. Now question 2. Find the value of the following polynomials at P0, P1 and P2. So you understand the question? You are given over here 4 polynomials and you are asked to find the value of P0, P1, P2. This is exactly the same which what we have done in the question number 1. In this, you are given the value of x as 0, x is equal to 1 and x is equal to 2. The three values given to you are x is equal to 0, x is equal to 1 and x is equal to 2. So it's exactly same. We will substitute the value of x as 0, 1 and 2 for all the given 4 polynomials. So let's do the questions one by one. First part, py is equal to y square minus y plus 1. So this is the polynomial. First I will keep the value as 0. So I'll substitute the value of the variable as 0. So p0 is equal to y square means 0 square minus y means minus 0 plus 1. So this is equal to 0 minus 0 is 0 only. So you are left with 1. Now I'll put the value of y as 1. Because we are given, we have to find p0, p1 and p2. So now I'm putting the value of y as 1. So first term was y square, so I got 1 square, minus y means minus 1, plus 1. So this is equal to 1 and minus 1 plus 1 cancels out. So I'm left with only 1. Now p2 is homework for you all. You will do it by yourself. Now the second part. Pt equals to 2 plus t plus 2t square minus t cube. So again first I'll find p0. So I'll write p0 is equal to 2 plus t. So instead of t I will write 0 plus 2t square. So I will write 2 0 square minus t cube means 0 cube. So what I am left with is all these terms become 0 except 2. So is this clear to you all? For all the polynomials, when we substitute the value of the variable as 0, the only remainder that is left or the only answer that is left to us is the constant term. Okay? You can see in all the questions when we put the value of the variable as 0, the answer left to us p of 0 is always the constant term. See, in the first question we have py, the constant term was 1, so p0 was 1. In the second question we have pt, the constant term was 2 only, so the answer was p0 was 2. You know the constant term, you all remember we have discussed in the first video of chapter 2. Constant terms are those terms which value do not change or they have a fixed value. They can be symbols also, like pi was a constant if you all remember. So these are those terms or those numbers or those symbols whose values do not change. Now the third part, px is equal to x cube. So in this again I'll put 0. So p0 is equal to 0 cube. This is equal to 0. Now why this is 0? Because over here there is no constant term. So it is 0. Now I will solve for p1. p1 for px is equal to x cube. So p1 is equal to 1 cube. I'll write x as 1, so it's 1 cube. 1 cube is equal to 1. So now we come to the fourth part, p of 0. So again I will put the value of p as 0. So p of 0 is equal to x minus 1 means 0 minus 1 multiplied by x plus 1 means 0 plus 1. So I am left with minus 1 and plus 1 in the brackets. So minus 1 multiplied by plus 1 is equal to minus 1 itself. Now the second part, p of 1. I'll write p of 1 is equal to x minus 1 means 1 minus 1. X plus 1 means 1 plus 1. So this is equal to 1 minus 1 is 0. So this is equal to 0. Now the other parts are homework for you all. And this PT which I haven't explained, you try to understand it by yourself. If you have any doubts, let me know. Now question number 3. There are 7 parts in question number 3. Let's start. Few are homework for you all which I haven't done over here. You have to do it by yourself, and let's discuss the remaining part. What we have to do is verify whether the following are zeros of the polynomial indicated against them. When the value of x, whatever is given or whatever variable is mentioned over there, it's whether pt or px or py, it is called a zero only if when we put that value in the whole polynomial, the answer turns out to be 0. Let's see what I am saying. If you all are not able to understand, let's see with example. The first polynomial given is px is equal to 3x plus 1. Now we have to find that x is equal to minus 1 by 3. So this is the value at which we have to check whether the given polynomial px is equal to 3x plus 1 is 0 or not. So what we will do? We will substitute the value of x as minus 1 by 3. So I will write p of x means p of minus 1 by 3 equals to 3x. Instead of x, again I will put minus 1 by 3 and plus 1. So on solving this, I will get 3 and 3 cancels out. 3 and 3 cancels out, and I am left with only minus 1. So minus 1 and plus 1 is equal to 0. So since p of minus 1 by 3 is equal to 0, therefore yes, this is a 0 of this polynomial. So this was asked in the question. So this is how you decide whether the given value of x or the given value of whatever variable is there is a 0 of that polynomial or not. Let's do the second question. P of x is equal to 5x minus pi. Now we have to check this value at x is equal to 4 by 5. So how will we do this? We will again put the value of x as 4 by 5 wherever it's given in the polynomial. So I'm writing it as p of 4 by 5 is equal to 5 into x means 5 into 4 by 5 minus pi. So now 5 and 5 cancels out. I am left with 4 minus pi. So since I am left with remainder over here, this is not turning out to be 0. Therefore, this is not a 0 of the polynomial. The value of p of 4 by 5 is not equal to 0. Therefore, this is not a 0 of the polynomial. Now the third question. P of x is equal to x square minus 1, where x is equal to minus 1 and plus 1. So we have to check this at both the values. So again I'll do same process. I'll keep the value of x as minus 1 first, then plus 1. So let's start with minus 1. P of x means p of minus 1 is equal to x square means minus 1 square and minus 1. So this is equal to minus 1 whole square means 1 only. 1 minus 1 will give you 0. So yes, minus 1 is a 0 of the polynomial. Now let's take the value for plus 1. P of plus 1 is equal to x square means 1 square minus 1. So 1 square is 1 itself minus 1. So this is 0. So yes, plus 1 and minus 1 both are the zeros of the given polynomial. Now the next question, p of x is equal to x plus 1 into x minus 2 at x is equal to minus 1 comma 2. So we have to check whether it's a 0 at minus 1 and 2. So again what we'll do, we'll put the values of x as minus 1 and 2 in the given polynomial. So p of x means p of minus 1 equals to x plus 1 means minus 1 plus 1 multiplied by x minus 2 is given there. So value of x is minus 1 minus 2. So on solving this I get minus 1 and plus 1 turns out to be 0. The first bracket becomes 0. So this whole solution becomes 0. So yes, I can conclude that minus 1 is a 0 of the polynomial. Now I will check this at 2. So I'll put P of 2 is equal to x plus 1 means 2 plus 1. In brackets, x minus 2 means 2 minus 2. Over here also 2 minus 2 turns out to be 0. So the second bracket is 0. That means P2 is equal to 0 because 0 multiplied by anything will give you 0. Now the fifth question. Px square, Px is equal to x square. Where we have to check the value? At x is equal to 0. So now we will put x is equal to 0. So P of x means P of 0 is equal to x square means 0 square. So this is equal to 0. Now next question, Px is equal to Lx plus m, where x is equal to m divided by L. So you can see over here we have three terms L, x and m. But the question is given P of x, means x is the only variable over here and L and m are considered to be constant terms. So we will put the value of x as minus m by L. So I get P of x means P of minus m by L is equal to Lx means L multiplied by minus m by L plus m. So L and L cancels out. I am left with minus m and plus m. So minus m and plus m also cancels out. So this is equal to 0. So yes, this is a 0 of the polynomial. So x is equal to minus m by L is a 0 of this polynomial. Now next question is homework for you all. You will do it yourself. Now we come to Px is equal to 3x square minus 1 at x is equal to minus 1 by root 3 and 2 by root 3. These are the two values at which we have to check. So let's check it at x is equal to 2 by root 3. 1 by root 3 is homework for you all. So I will put Px. Px means P of 2 by 3. Instead of x, I will put 2 by under root 3. This is equal to 3x square. So again instead of x, I will put 2 divided by root 3 whole square because it is x square minus 1. So what I will get? 3 into 2 square is 4 and under root 3 square is 3. So this 3 and 3 cancels out. So I am left with 4 only and 4 minus 1 is equal to 3. So x is equal to 2 by root 3 is not a 0 of this polynomial. Now the last part remaining is homework for you all. Now we move to the fourth question. Find the zeros of the polynomial in each of the following cases. Now you all know what the zero is. How do we find out the zero? It's given Px is equal to x plus 5. For any number or for any polynomial, if we have to find the zero, what we do is we equate the polynomial to 0. That is, simply we write the polynomial as equal to 0. We write Px is equal to 0. So this is what we will do for all these questions. Px is given x plus 5. So I will write x plus 5 is equal to 0. So this implies that x is equal to minus 5. I will transpose this 5 to the right hand side. So I'll get x is equal to minus 5. Second question, Px is equal to x minus 5. Again over here I will equate Px is equal to 0. So I'll get x minus 5 is equal to 0. And this implies that x is equal to 5. I will transpose the 5 to the right hand side. Third part, Px is equal to 3x minus 2. Again I will equate the polynomial to 0. So I will get 3x minus 2 is equal to 0. So this implies that 3x is equal to 2. I will transpose the minus 2 to the right hand side. So minus 2 becomes plus 2. Because when we transpose the sides, the sign changes. So the value of x is equal to 2 divided by 3. We do cross multiplication. We bring the numerator to the denominator so that we can find the exact value of x. It was 3x is equal to 2. I will bring the numerator to the denominator to find the exact value of x. Next question, px is equal to 3x. So again I will equate it to 0. 3x is equal to 0. So now you know that 3 cannot be 0. So what will be 0 for this whole term to become 0? For this expression to become 0, it is necessary that x is equal to 0. Only then 3 multiplied by 0 will be 0. Therefore, we get the value of x as 0. Next question, px is equal to 2x plus 5. So I'll equate px to 0. I will write it as 2x plus 5 equals to 0. So this implies that 2x is equal to minus 5. I have transposed the minus 5 from left hand side to the right hand side. In the left hand side it has a plus sign. Now it will have a minus sign. X is equal to minus 5 upon 2. We bring the 2 from the numerator to the denominator. Now we move to next question. Px is equal to Ax, where A is not equal to 0. See, it is clearly mentioned that A is not equal to 0. So again we will equate the question. Px is equal to 0, that means Ax is equal to 0. So this implies that x is equal to 0 because A is not equal to 0 is given in the question. So since A is not equal to 0, this means x is 0. Now the last part and the last question of the exercise. Px is equal to Cx plus d, where C is not equal to 0 and C comma D are real numbers. So let's see how to solve it. Again we'll do same. Px is equal to 0. So Cx plus D is equal to 0. So this implies that Cx is equal to minus D. We will transpose the D. So sign also changes. So this implies that x is equal to minus d upon c. We have moved the c from the numerator to the denominator. It is clearly given in the question c is not equal to 0. So therefore this is a rational number. So thank you students. We have completed this exercise. If you have any question, let me know. We will discuss it again in the next class. And don't forget to practice maths.